in continuation with trigonometry from where we ended. So today we're going to do the 6 trigonometric functions of light angle triangles. So we have been given this light triangle here. So from this light triangle, we have an angle theta. So as I said earlier in the beginning of trigonometry, I said trigonometry mostly deals about with the light triangles or light angles triangles. So we have this right angle triangle which have been given with an angle theta. So from this angle theta, you can see you have an opposite side. So this opposite side is because it's opposite to the what? See, the angle which is theta. We also have an adjacent side. Adjacent means next to the angle. We also have an hypotenuse. So when dating back to your previous from high school, you had something else you were doing that was known as so Toa. So SOHCAHTOA mostly deals with 3 trigonometric functions, which is sine, cos, and tan. So SOHCAHTOA means sine of opposites and hypotenuse, cos of adjacent and hypotenuse, and tan of opposites and adjacent. So now under trigonometry, we don't just have these 3. We have others. So for now there are more. They're not just 6 as we have mentioned here. There are more than 6, but for now we only going to focus on 6 of them. So from this same triangle, I'll introduce to you these other 3 which we also have. So let's start with so we have first one which is so from we'll start with sine. So S means sine, so we have sine theta, which is given by O means opposite, so we have opposite over H means hypotenuse, which is HIP. Then we go to C means cosine, so which is cos theta is given by A means adjacent, which is adjust over hypotenuse. We also have tan, so T means tan theta, which is given by O is opposite and A is adjacent. So now we also have other trigonometric functions. So from sine, so we have sine theta. So the inverse of sine theta, so 1 over sine theta is given by cosec theta. So from this sine theta here, the function for sine theta, if we do an inverse of the function of sine theta, we have what is called cosec theta. So we have 1 over sine theta, we have said it's opposite over hypotenuse, which is this is all given as to cosec theta. So since you have 1 over here, these two will just interchange since 1 is an inverse. So an inverse will be hypotenuse over opposite is given by cosec theta. This is another trigonometric function that we have. So cosec theta. Then we also have cos. So 1 over cos theta gives us sec theta. So sin theta cos theta we have said it's adjacent over opposite hypotenuse, which is sec theta. So sec theta is therefore hypotenuse over adjacent. We also have now tan theta. So 1 over tan theta. So 1 over tan theta is given by, so tan theta we have said it's opposite over adjacent. So here we have now adjacent over opposite, which is given by 1 over this. which is cot theta. So when you interchange the function for tan, the trigonometric function for tan, when you make an inverse of it, you have what you call cot theta. So let me give a recap of what we have talked about. These others we have introduced. So from we have sin theta, cos theta, tan theta, which is also giving us sin is taking us towards cosec theta, cos is giving us to sec theta, tan is giving us to cot theta. So let me give you a simple linkage for you to fully understand them, so that you cannot be confusing yourself, because this cosec, sec and cot, you're not very familiar with them, so you can be confusing yourself. But for you to simply understand what cosec theta is, you go to cosec here. You see cosec, so you count 1, 2, 3. On the third position, you have what? You have an S. So you check under the three sine functions, you know which one starts with an S. It's sine theta here. So sine theta, cosec theta. You go now to sec theta. You also count 1, 2, 3. What's the third letter? The third letter it's a C here. Which sine function has a C? It's cos theta. So cos and sec are opposites of each other. You go to cot theta. Again, you count 1, 2, 3. What's the third letter? You have T here. What's the first one? T here as well. So tan and cos are also an inverse of each other. So for you to fully understand these six trigonometric functions, let's do some examples so that you can fully understand them. So we have example 1, which is saying find the values of the 6 trigonometric functions of theta for the triangle given below. So we have been given this triangle below, which with an angle theta. It has a side with the opposite side with a 3, an adjacent side with a 4, and an hypotenuse side. So from the hypotenuse sides, we have not been given anything. So how can you find now the value which is here? Because we don't know that we have to find the value which is here for us to find the answers. So we'll do something like, from high school you also learn something like this: hypotenuse squared. Okay, hypotenuse is equal to root of opposite squared plus adjacent squared. So which is equal to, so for us to find the hypotenuse, we have to find the root of opposite squared plus root adjacent squared. So what's our opposite? Our opposite, we have 3 squared plus 4 squared. So root of, what's 3 squared? 3 squared, it's 9, plus 4 squared, it's 16. 9 plus 16 is root of 25. Root of 25 is giving us 5. So our opposite side, hypotenuse here, is 5. So now let's answer now the 6 trigonometric functions using what the given information. So we can even start with sine. So we have sine theta. So sine theta is given by opposite over hypotenuse. So which one is our opposite? Our opposite is 3. Hypotenuse 4. You are done. Cos theta. Cos theta is equal to. So under cos theta, it's adjacent over hypotenuse. What's our adjacent? It's 4 over 5. Oh, sorry. From here, it's opposite over hypotenuse. So opposite is 3. Our hypotenuse we have found is 5. So 5 here, sorry. Then we go to tan theta. So tan theta is given by, tan theta it's opposite over adjacent. So our opposite side is 3. Our adjacent is 4. Then you go now to cosec theta. Cosec theta. Cosec, we said it's the inverse of sine. So cosec is hypotenuse over opposite. So our hypotenuse side is 5 over 3. As you can see, these two have just interchanged to give us this. Then our sec. So sec theta, we said it's hypotenuse over adjacent. So it's 5 over 4. And our cot theta. So cot theta is adjacent over hypotenuse, which is giving us 4 over 3. From here, it means you are done because you have answered all the 6 trigonometric curves: 1, 2, 3, 4, 5, 6, which is sine, cos, tan, cosec, sec, and cot. Then let's go to our example 2. Our example 2 says, given that theta is an acute angle, and cos theta is equal to 5 over 8, find tan theta. When you go back to angles, acute angle is an angle which is between 0 degrees and 90 degrees. That's an acute angle. So now we have been given cos theta. So this theta is an acute angle. So which is given by is equal to 5 over 8. Find tan theta. So how will we find this? So we first have to understand what is cos theta. We said cos theta is equal to adjacent over hypotenuse. This is a j over hypotenuse, which is so this 5 here is our adjacent and the 8 is our hypotenuse. So now from these two you can find now since you are only have the adjacent and the hypotenuse, you can find what's the opposite. So how do we find the opposite? So to find the opposite, so to find our opposite side, so the formula is opposite is equal to root of hypotenuse squared minus adjacent squared. So which is root of, so we have 8 squared minus 5 squared. What's 8 squared? 8 squared is 64. 64 minus 25. What's the answer giving us? So root of 8 is 64 minus root of 5 squared, which is 25. So 64 minus 25 is giving us root of 39. So 39 doesn't have a root. So we end from here. Then now we can find tan theta. So tan theta is given by tan theta is equal to opposite over adjacent, which is equal to our opposite is root of 39 over our adjacent is 5. It means you are done. That's how we answer these questions, and these questions are very common in quizzes, tests, and exams. You will find these questions about trigonometry always. So you just have to master the concepts. You know it by heart. That's how you answer these questions.